d'adaptation que nous pouvons entreprendre. Donc, en résumé, la vulnérabilité, c'est l'exposition à un risque de changement climatique conjuguée aux capacités d'adaptation propres. Et l'adaptation au changement climatique, d'après l'IPCC toujours, c'est un ajustement dans les systèmes biologiques, sociaux ou économiques en réponse à des stimuli climatiques, leur effet ou impact, 1. Pour réduire la vulnérabilité, 2. Pour atténuer les dommages et 3. Pour saisir les opportunités. Donc, l'adaptation au changement climatique, ce n'est pas toujours négatif. C'est vrai que l'adaptation au changement climatique, c'est pour réduire la vulnérabilité, pour atténuer les dommages, mais c'est également parfois pour saisir des opportunités. Et moi, j'insiste beaucoup sur cet aspect positif et je vais vous en parler. Maintenant, quels sont les changements climatiques déjà observés? Déjà observés, hein? Bon, là, j'ai un petit... comme réponse, j'ai une petite vidéo que je vais vous montrer. C'est une vidéo de 1 minute, elle va tourner, je vais la tourner une seconde fois et je vais prendre un peu de temps pour vous expliquer. C'est une vidéo qui a été élaborée par la NASA sur la base de données de température observées et de données satellitaires. Donc, elle a combiné les deux pour faire des données en points de grille de la température de la surface de la Terre pour la période comprise entre 1885 et 2012. À partir de cela, on a fait la moyenne sur cette période 1885-2012 et on a fait une vidéo en faisant dérouler année par année. Je vais la reprendre, elle est presque terminée. Tout ce qui est en bleu, ça veut dire que c'est inférieur à la moyenne. Lorsque c'est jaune, rouge ou orangé, c'est supérieur à la moyenne. Donc, on va la dérouler de nouveau. C'est 1 minute, on va la dérouler de nouveau. Voilà. Donc, à partir de 1885, pardon, excusez-moi. Là, on est dans les années 1900. Là, c'est là. Vous allez voir, elle va rougir, là. حشمة منها حترمينا فيها برشا. Donc oui, la réponse est là. La température a augmenté de manière plus ou moins contenue depuis le début du siècle dernier. En Tunisie, nous avons commencé à observer des augmentations de la température de manière régulière à partir des années 1975. Qu'est-ce qu'on a observé de nouveau? Pour les extrêmes de chaleur, c'est le premier graphique là. Et là, c'est la région méditerranéenne. Et comme vous pouvez le constater, nous avons une augmentation des extrêmes de chaleur, je ne sais pas si vous voyez très bien, avec 3 points. Ça veut dire avec un... Oui, c'est mieux. Voilà. Donc, pour la température, là, nous avons une augmentation de la température pour la région méditerranéenne. Donc, pas de la température, une augmentation des extrêmes thermiques avec 3 points pour dire c'est une augmentation avec une grande fiabilité. Pour les extrêmes de précipitation, pour la région méditerranéenne, c'est du blanc sale à peu près. Ça veut dire qu'en fait, on n'a pas encore de tendance claire à l'augmentation ou à la diminution. Donc ça, c'est un peu ce qu'on a observé pour la Méditerranée. Pardon? Ah, Michel, je sais pas. Là, c'est pour les sécheresses agricoles et écologiques. Et ah non. Pour les sécheresses agricoles et écologiques, et vous voyez que la Méditerranée, il y a une augmentation des sécheresses agricoles et écologiques avec 2 points pour dire que c'est avec une fiabilité importante. Et vous, comme vous pouvez le constater, lorsqu'on voit un peu le monde, il y a uniquement 2 régions, qui est la région méditerranéenne, et là, c'est la région où donc il y a 2 régions dans le monde, qui est la Méditerranée et la région de l'Amérique, l'ouest, la partie ouest de l'Amérique, nord-ouest de l'Amérique, la région de Californie, où on a observé une augmentation dans les sécheresses agricoles et écologiques. Donc ça, c'est ce qui a été observé jusqu'à maintenant. Maintenant, et c'est ça, c'est une diapo que j'aime toujours présenter. Elle n'est pas très scientifique, mais elle nous donne une idée un peu, une autre perception. Ça, c'est un peu la perception des acteurs locaux en Tunisie, parce que je me suis beaucoup promené en Tunisie et j'ai eu l'occasion de parler avec beaucoup de gens et il y a eu des témoignages. Il y a plusieurs qui me disent que le temps n'est plus comme avant. Il y a d'autres qui m'ont dit que la baisse, qu'ils ont observé une baisse dans les rendements des arbres fruitiers, essentiellement au niveau de la région de Sbitla ou le Gasserine. Je m'attabarche à la région avec. Et là, ça s'explique parce qu'en fait, dans cette région-là, on fait la culture des arbres, des fruits à pépins. Et les fruits à pépins, pour leur développement, ils ont besoin d'un nombre de jours de froid bien déterminé. Avec l'augmentation de la température que nous avons commencé à observer depuis les années 1975, ce nombre de jours de froid a donc diminué. فما كل مخر يسمعوا يقولوا الشجره هبلت معناها الكومونس نورت من ساعات فما عام ولا زوز لقيناه منور من جانفي. Il y a aussi les cigognes. Les gens du nord-est, ils nous disent que les cigognes arrivent plus tôt qu'avant. Avant, ils nous disaient que les cigognes arrivaient au mois de mars. Maintenant, parfois, ils arrivent même fin janvier, ils sont là. Il y a aussi au niveau du golfe de Gabès. Les gens nous disent que ils ont observé dans les années 90 des crustacés orangés et chouailles qui sont originaires de mers chaudes, comme la mer Rouge. Et là, c'est un signe que la température de la mer du golfe de Gabès a augmenté. Donc ça, c'est un peu la perception un peu des acteurs locaux du changement climatique déjà observé. Maintenant, pour le futur. Qu'est-ce qu'on s'attend pour le futur? Au niveau global, ça, c'est l'augmentation de la température au niveau global pour le scénario SSP2. Le scénario SSP2, c'est le scénario à peu près, comme on dit les Anglais, près du business as usual. Ça veut dire si on continue à peu près au même rythme que maintenant. Et là, c'est l'augmentation de la température pour le scénario SSP de 8.5. C'est le scénario le plus pessimiste si on ne fait rien d'ici la fin de ce siècle. Donc, on s'attend à une augmentation de la température. Elle sera plus importante au niveau des régions continentales qu'océaniques. Elle sera plus importante au niveau de l'hémisphère nord que de l'hémisphère sud. Ça, c'est pour la température. Ce tableau permet de résumer avec un seuil, 1,5 et 2 degrés, et je vais expliquer pourquoi ce seuil-là. Je pense que vous êtes au courant qu'en 2015, il y a eu l'accord de Paris sur le climat. Il a été signé en 2015 et ratifié en 2016 par un grand nombre, par la majorité des pays. L'objectif de cet accord de Paris, c'est de contenir l'augmentation de la température d'ici la fin de ce siècle, à 2 degrés, voire 1,5. Donc, l'objectif de l'accord de Paris, c'est que l'augmentation de la température d'ici la fin de ce siècle ne dépasse pas 2 degrés et qu'elle soit aux environs du 1,5. Et là, comme on peut le constater malheureusement, déjà, dans tous les scénarios, la température va continuer à augmenter au moins jusqu'à 2050. Au moins. Et le deuxième résultat, c'est que nous serons, ça c'est l'échéance 2100, et probablement dans la plupart des scénarios, dans les 3 scénarios, nous serons au-dessus de cet objectif de 2 degrés. Donc, la trajectoire actuelle que nous avons ne nous permettra pas d'atteindre les objectifs de l'accord de Paris. Pourquoi ce 2 degrés en fait? Parce que les scientifiques ont estimé qu'au-delà de 2 degrés, les impacts du changement climatique seront très forts et parfois même irréversibles. Pour les précipitations, toujours, là, ça c'est le SSP2 4.5 et ça c'est le SSP2 8.5. Pour les précipitations, la configuration est différente. Ça veut dire qu'en fait, on aura des régions où il y aura des augmentations de précipitations et d'autres où il y aura des diminutions de précipitations. Pour cette région-là, pour le Sahara, où est-ce qu'il est le Sahara? J'arrive pas à bien voir. Voilà, il ne faut pas trop en tenir compte parce que les modèles ont du mal à reproduire le régime de précipitation des régions vraiment sahariennes avec des précipitations qui sont de 50 mm, voire moins parfois. Donc, des régions où il y aura plus de précipitations et des régions où il y aura moins de précipitations. Et malheureusement, nous n'avons pas de chance. La région méditerranéenne sera l'une des régions où on aura moins de précipitations attendues. Voilà. Maintenant, on va raisonner un peu en augmentation de la température, puisqu'on a vu que plus la température va augmenter, c'est inéluctable, et plus l'augmentation de la température sera importante, plus les impacts seront importants. Donc là, on raisonne, là c'est l'impact pour les précipitations, pour une augmentation de 1,5 de la température, pour une augmentation de 2 degrés de la température, pour une augmentation de 4 degrés de la température. Et comme on peut le constater, globalement, c'est la même structure, mais plus la température va augmenter, plus il y aura des différences entre les zones où il y aura plus de précipitations et les zones où il y aura une baisse de précipitations. Et malheureusement, comme on l'a déjà dit, la région méditerranéenne, c'est celle où il y aura une baisse de précipitations et ça va s'accentuer avec l'augmentation de la température. Là, c'est l'humidité et malheureusement, c'est le même constat. Il y aura une diminution de l'humidité au niveau de la région méditerranéenne. Maintenant, je vais vous présenter 3 diapos qui sont relatifs au changement climatique sur la Tunisie. Il y a eu 2 grandes initiatives en Tunisie. La première initiative, c'était en 2014-2015, qui a été faite par l'INM, l'Institut national de la météorologie, en collaboration avec Météo France. Et cela a permis de faire des premières projections de changement climatique sur la Tunisie avec une résolution spatiale de 12,5 km en utilisant les données du 5e rapport d'évaluation du GIEC. En 2021, il y a eu l'élaboration du du PNA, du Plan national d'adaptation. Et le bureau d'études qui a été chargé d'élaborer ce PNA, il a fait un protocole de collaboration avec l'INM. Il a pris ces données à une échelle de 12,5 km. Il a fait un downscaling de jusqu'à 5 km. Donc, globalement, 2 initiatives. Une première en 2014-2015 et une deuxième en 2021 dans le cadre de l'élaboration du Plan national d'adaptation. Je vais vous présenter les résultats sur la Tunisie. Globalement, sur la Tunisie, on s'attend à une augmentation de la température entre 1,6 et 1,9 d'ici 2100, 2050. Pour la Tunisie, je vous présente d'ici 2050. On s'attend à une augmentation de la température entre 1,6 et 1,9 d'ici 2050. L'étage saharien sera l'étage le plus affecté. Et ces augmentations seront homogènes, similaires aussi bien pour T-min que T-max. Les deux types de température vont évoluer dans le même sens. On observera un effet modérateur de la mer. Donc, en fait, le réchauffement au niveau des régions côtières sera moins important qu'au niveau des régions continentales. Ce réchauffement sera plus accentué en été et statistiquement significatif. Ça veut dire, il n'y a pas de secret, nous allons vers cette augmentation de la température et c'est un peu là où va le climat mondial. Il n'y a pas de secret. Mais toujours à l'horizon 2050. Pour les précipitations, c'est un peu plus compliqué à interpréter. On aura une diminution des précipitations, certainement plus importante au niveau des étages humides que des étages secs, plus importante en automne qu'en hiver, et ces tendances à la diminution ne sont pas statistiquement significatives en 2050, mais ils deviendraient significatifs d'ici 2100. Donc il y a une certaine ambiguïté. Pour les précipitations, les résultats ne sont pas aussi clairs que pour la température. Bon, là c'est les extrêmes. Mais pour vous dire très rapidement, pour les extrêmes thermiques, on aura une augmentation des jours de canicule et une diminution des jours de froid. Et pour les extrêmes de précipitation, il y a un peu
extreme rainfalls, there is still ambiguous, not as clear. There may be an increase of humid days and globally an increase of humid days, and even if that's not clear as to the number of days above 10 millimeters. For rainfall, it's not always clear, and it applies to all countries, not only for Tunisia. The parameter of rainfall does not have a potential of prospective as that is as high as for temperatures. Now, for those who are not familiar with it, the IMM has established a website, climate/c.tn, where it made it accessible for donors to give climatic changes up to the 2100. Therefore, you can get data, you can even request data, and it's free of charge without any payment. These data are prospective data for climatic changes up to 2100. This is the overall presentation. In fact, do you have a socket around?
مش حتى الاورديناتور. pensais que c'était mon ordinateur.
Well, that is somewhat the content of the portal, what you can have through it. Temperatures, minimal temperatures, maximal temperatures, and so on. And as I've already mentioned, you can even start by requests. I therefore invite you to visit this website. It's very interesting. And I believe that in scientific terms and technical terms, the projections of climate change that you will find on this portal are largely technically more interesting than the ones that you may extract from some other global models that have resolutions of 20 or 30 kilometers. All you have to do is to be wary and be attentive. Sometimes they give you options of an average of one particular province. Here, I do not advise you to use that, for at times you'll have provinces that cover two or three climatic regions, and the result will be erroneous. Therefore, we should now talk about this well-noted vulnerability for climate that will certainly exacerbate the conditions of drought and aridity. Now we have it there. Therefore, this is for the prospective projections. This is the frequency and intensity of extremes of temperature. Let me read it somewhat with you. Here you have an extreme of temperatures over 10 years, which currently is reproduced 2.4 times every 10 years. An extreme temperature that happens or takes place 2.4 times in 10 years currently, with an increase of temperatures of 1.5 degrees. It will take place 4 times. With 2 degrees it will reproduce 5.6 times, and with a temperature of 4 degrees it will reproduce 9.4 times every 10 years. To be more brief, an extreme temperature which currently today it takes place once every 10 years. With an increase of 2 degrees, it will take place twice every decade. With an increase of 4 degrees, it will take place 3.5 times every decade. The other table for the extremes for 50 years. For extremes of rainfall, if you take an extreme that is taking place currently 1.3 times every decade, 1.5 degrees it will take place 1.53. For 2 degrees it will take place 1.7 times every decade, and 4 degrees it will take place 2.7 times every decade, which means, to be brief, an extreme rainfall which currently takes place once every decade. In the case of the increase of temperature of 4 degrees, it will take place twice every decade. Here you have the SPA, the indicator. The SPI, the indicator of standardized rainfall. As usual, this is for the scenario SSP2 4.5. This is scenario business as usual, and this is SP2 8.5. This is an extreme scenario. And here for the Mediterranean region, unfortunately, you can see a drop of the SPI, which is relatively moderate for the first scenario, and which becomes very important in these regions for an increase of 4 degrees in temperature. Well, in addition to these extreme climatic changes that will exacerbate the conditions of drought and rainfall, there is also what we call climate impact drivers, that is, climatic first-degree impacts. That they are at 4 levels. The first one is at the physical level. The second climatic change is at the biophysical. The third one is at the economic, and the fourth one is at the social level. The last two socio-economic are the most important impacts, the most virulent. I'd like to present to you some results concerning what we know as climate impact drivers. Here, for the biodiversity, for 1.5 degrees, an increase of temperature of 1.5 degrees, 2 degrees, 3 degrees, and 4 degrees. And you can see that there is a drop in biodiversity at the level of the Mediterranean region, which will increase with the increase of temperatures. Fortunately, for once, we are not the most unfavored region. We have analyzed the different maps, and the most unfavored ones are the arid and semi-arid regions of Kalahari, where we shall increase major losses of biodiversity. For hydraulic drought, in the past, for the Mediterranean, we observed drought drop. Tendency in the past, an increase of droughts, biological droughts with that are due to climate, and for the future, this will be further confirmed, unfortunately. Here, this is for agricultural droughts, approximately the same principle. If we consider that in a particular region we have a drought, agricultural drought, of 1.7 times every 10 years, for an increase of 1.5, it will be twice. For an increase of 2 degrees temperature, it will take place 2.4 times. For an increase of 4 degrees, it will take place 4 times. Therefore, to be brief, for an increase of temperature of 2 degrees, the frequency of droughts, agricultural droughts, will increase by 1.5. That means a drought that today has a probability of twice every decade with a temperature of 2 degrees, it will take place 1.5 times, and with an increase of temperature of 4 degrees, it will take place 2.5 more times every decade. I believe that we have enough of the bad news. Maybe we should move on to some opportunities. And if you recall, in the definition of adaptation, we already said reducing vulnerability, avoiding damages, and taking a chance of opportunities. What I'll present here is a study that I've made with 2 colleagues from IRA. I don't know whether they are around with us or not. I have in mind, I believe they're not with us, otherwise they would have risen. I will recall their names. This is a study that I undertook for the GZ. No. 2 colleagues from IRA, actually. I've forgotten their names, so I shall recall it. This is a study that we undertook for GZ. They asked us to look into the potential of sequestration of carbon in the semi-arid and arid regions. Our mission consisted in making calculations to evaluate the potential for 5 countries of the MENA region: Tunisia, Morocco, Egypt, Jordan, and Algeria. That's it. Therefore, I'll present you these preliminary calculations that we made. This is just an exercise, a simple calculation, just to give you an idea of what may happen and let you realize that there is potential. Therefore, here the FAO estimates that there is 3.5 billion hectares of land that may be divided between that 200 picogram that are held. The major characteristic is that the majority of the carbon in the semi-arid and arid regions can be found in the soil. The approach is, in fact, to maximize the productivity of root and plants. In an arid environment, we have an increase of 4 tons per hectare. In tropicals, we have a drop of 7 to 10 tons per hectare. In tropical regions, it will be between 7 and 13 tons. For temperate region, between 11 and 13 tons. And for boreal, polar, alpine regions, between 21 and 24 per hectare. Therefore, as you will note, the potential of drop in the arid regions is not particularly important. Therefore, what does that mean? That means that even if the potential in these semi-arid and arid regions is not as important, the areas are so large, and the combination of this low potential with the large and important areas could give us an interesting potential. Therefore, I'll very briefly go through some figures.
Là, c'est pour l'Algérie.
Here for Algeria, we worked on an example that the rehabilitation of 3 million hectares. This is an idea that we took from the third national communication of Algeria under the Convention on Climatic Change. We undertook a study, a project for 5 years to implement the project, and that will last for 25 years, another 20 years. And we noted that we could reach and accumulate, and for the 25 years, 125 million tons of carbon. This is the case of Algeria. In the case of Egypt, which is not very important, actually, we didn't find much. We took an example, the restoration of 10% of the total area of Greenland in Egypt. This is 700,000 hectares, and which an average of 25,000 tons of carbon. This is not that important in 1 year. It is just 1 million. That's not that important. For Jordan, this is probably the country where the potential is the highest. We had sufficient information. We had 2 projects and 2 activities. The first one is 5% of the territory of Al-Badia, with a precipitation less than 100 millimeters. And the second activity is the restoration and regeneration of the land of 100,000 hectares in the Badia, where precipitation is between 1 and 120 millimeters. The accumulated potential is around 21 million tons of carbon. This means 0.8 tons per year. This is a figure that is important if you take into consideration the potential of sequestration in Jordania.
Pour le Maroc,
for Morocco, therefore, we have 3 activities. The first one is the conversion of marginal lands and forests over an area of 45,000 hectares, forestation of olive trees over a region, an area of 500 hectares, the conversion of prairies over 500,000 hectares, with an increase of the stock, the animal stock, around 35,000. And here we can reasonably say that we have a potential that is not, that is interesting, around 123 million tons of carbons over 25 years. And certainly the activity, that is most interesting in terms of sequestration of carbon, is the rebuilding or reforestation of olive trees. For Tunisia, we took 3 major activities: rebuilding of olive trees and restoration of the alpha steps in gathering and prairie pasture land and actions for in the southern region. The increase for the olive trees is around 11 million tons of carbon. For regeneration of Greenland, 6 million tons of carbon, and for the prairie regions over pasture land is 21 million tons. The total is 145 million tons. This is quite interesting, however. Now, in Tunisia, we have had this reminds me actually of my intervention of yesterday. We have a relatively major strategic reflection. What matters most is their execution. And let's talk about two particular initiatives in this area. The first one is the national strategy of resilience to climatic change. This is a strategy that we have set up, which took us 2 years to elaborate. It was established in March last year, and with our partners, and it's a strategy that is multi-sectorial with 6 activity sectors: agriculture, ecosystem, fisheries, water resources, tourism, health, and the littoral and coastal area, and 4 intersectoral axes: governance, research and innovation, financing, and social and territorial inequalities. Therefore, it has been structured in 10 strategic axes. For each axis, we defined strategic orientations, and for each strategic orientation, we identified measures of adaptation. Let me show you somewhat the configuration of this strategy. I'll let you read through it. Here you have the vision of this strategy. I like this vision. I read it out before. I find it quite interesting. A Tunisia that is resilient to climatic change, having significantly reduced vulnerabilities and strengthened capacities of adaptation of its ecosystem, its population, its economy, and its territories, and operating the necessary transformations to ensure a model of socio-economic, inclusive, and lasting economy. This is our strategy to the year 2050, with here the 6 sectoral axes and here the 4 transversal axes. In fact, why have we undertaken this strategy of resilience to climatic changes? It is within the framework of our commitment to the agreement, to Paris Agreement, within which all countries have been called upon to undertake a strategy of resilience per carbon for all countries. Tunisia is one of those countries that had chose to undertake a national strategy resilience per carbon and to climatic change. Therefore, I presented the part referring to climatic change for the strategy per carbon. I'm not that much an expert in that area, but I'll give you the most important. The objective of the strategy per carbon is to attain carbon neutrality in 2050, which means that by the year 2050, we hope that we will be able to absorb as much carbon as we can emit in the atmosphere. I fully agree with you that this will be a very ambitious objective with a lot of constraints. In order to attain this objective, all sectors will be called upon to make or to proceed to reductions of their green effect processes, and they reduce the emission of gas. And the sector that is known as AFAT means agriculture, forest, and land adaptation. This will be the sector that will need to make the most efforts to attain the objective globally. the aphid sector will seek, in combination with the drop of emissions and the increase of absorption, we shall have a factor of 8. Here you can see the energy in blue. This is the energy. Let me check again. In blue you have the energy. In dark blue you have the industrial processes. In gray the wastes, and here this is the aphid in brown, and you can see that the aphid will have to put in considerable efforts in terms of a reduction of greenhouse effect. Here you have the emissions, and this is how they will evolve to attain this level of 0. By the year 2050. To attain that factor, the aphid must put in greater efforts. This is the sector that will allow us to absorb the effects of the greenhouse effect. Its role is very important for agriculture, forests, but also the ecosystems. And here, the battle against drought, the battle against desertification, the preservation of the ecosystem, the regeneration of land, it will play an important strategic role that will combat desertification, but also in terms of cost and benefits to drop the carbon effect. And this is, in fact, an opportunity that those experts in the field should take on. Now, here I will go very rapidly. This is the National Plan of Drought. This National Plan on Drought, the objective drought, I let you read it. The National Program of Plan, it was elaborated in 2020. And I have a copy. Those who do not have it, I may distribute it to them. And here, I very much like this part with 3 components, and what pleased me so much in the drought plan is that there is a component of anticipative and early alert elements. For once, we start talking about anticipation or prospective studies. Thus far, we've been in the field of reaction. For once, we are now trying to look into the future, to anticipate, and not to let things hit us. This is what I liked so much. I believe that now I shall have to conclude. Unfortunately, therefore, the Mediterranean region is certainly a hotspot in terms of climatic changes. Climatic changes are already there, and we have seen many examples. In the future, we expect an increase of temperatures, a slight drop of rainfall, and globally a more variable climate. And this is the element that is the most concerning. That is the evolution of the means. We can absorb it, but what is difficult to absorb is the variability of climate. As you have seen, if you recall, the climatic changes could be, by the year 2001, could be 2 degrees or 3 degrees or even 4 degrees. And the amplitude of the climatic changes will increase with this increase in temperatures. And this will depend solely on the international policies and of the commitments taken by countries to combat climate changes. It will not depend on one single country, it will depend on the international policy in the area. We have more marked variability in our climate, and will certainly exacerbate the conditions of drought and desertification, with an increased frequency, more intense, with changes in heat, and we also have climate impact that will lead to a loss of biodiversity and an increased drought level, And therefore, in brief, climate change is the new challenge for the arid regions that are subject to drought and desertification. Thank you for your kind attention.
Merci Syriac pour cette riche présentation. Il y a pas mal, vous avez parcouru tous les aspects presque théoriques, pratiques, et vous avez même touché les informations données par les acteurs locaux. Donc ça explique bien ce que nous sommes en train de faire pour la recherche, c'est surtout expliquer le savoir-faire local des gens, quoi. C'est des Merci pour cette présentation. Peut-être vous avez pris un peu de temps. Je vais passer directement aux collègues pour les présentations. J'appelle Mounir Abichou pour la première présentation qui va toucher surtout l'impact de la recherche de changement climatique sur l'olivier en zone aride. Peut-être c'est une continuité d'hier parce que hier nous avons à la fin de la journée une présentation sur l'olivier qui a suscité beaucoup de discussions. Donc on va continuer sur cette thématique. Simone.
Merci, Monsieur le Président. Merci pour l'organisation de ce séminaire.
Merci.
Mon exposé intitulé L'oliculture pluviale face au changement climatique, rareté et dégradation des ressources naturelles.
Is entitled Rainfall Agriculture while facing climate change. Most of the time, we cannot say that only the climate has changed, that the soils have changed, the agricultural practices have changed, so we are dealing with global changes.
L'olivier conduit en pluvial constitue le principal et l'unique culture.
And their growing is conducted while using rainfalls, and the olive tree is a means for valorizing the small quantities of water which are not available in the south. Since we are dealing with a rainfall system, we know that it's a system based on rainfall. The olive tree is considered as the most available aspect, so as to develop agriculture. So the olive tree can seize the atmosphere and capture the atmosphere, and but this channel, the olive tree channel, is the source of speculations in the economical, cultural, social field, and so we have to find the necessary means for improving productivity and limiting the negative impact of climate change and the lack of human resources. But how can we improve the output of the olive tree while using a rainfall system in the context of impact of climate change and within a social economical context, which is quite difficult in the mountainous areas? The olive tree has been existing for 15 centuries, and its growing is based on the valorization of runoff water resources And even if you take into account the architecture of the olive tree, it has been designed so as to protect the olive tree against evapotranspiration. And you can have an idea about the state of the art of the olive trees after 4 years of drought. And the olive tree has resisted. So the olive trees have a better resilience to climate change. At the beginning of the 20th century, we had an extension on sandy plains which are limiting the shoreline. So they have chosen the deep soils which are adapted to the olive trees, and the sector has played its social, economical role in best conditions. And with the production of olives, we have transited from a production of 400 kilos per olive tree to 600 kilos per olive tree. And we have made projections over 130 years, and you can see that we have the same site, the same agricultural practices, the same variety of olive trees, and you can see the difference between an olive tree which has exceeded 140 years and an olive tree which is existing for 40 years. There is no difference. And so as to give an idea about the old aging criteria, I would like to say that the region has not changed, but the favorable conditions we choose to exist are no longer existing. The various factors to take into account are the climate change, the lack of water resources for irrigation, and even if we have some water resources, their quality is characterized by the rise of salinity. And you have noticed that within the 2 last decades, there was a rise of temperature, and it has contributed to the development and the progression of the blooming. And those factors had a negative impact on the quality of olive oils, and we had extreme events such as very abundant rainfalls. And here on the slide you have the evolution of the temperatures since the 70s, 1970s, as it has been said by Mr. Leben. There was a rise of temperature with difference between the maximum temperature and the minimum temperature, and we have studied the phenological variations while studying the phenological reference while using a series of available observations dealing with the phenology of the olive tree while using the data coming from the station which is based in Tataouine. And we have taken into account all the elements which highlight the values existing during the blooming period, and we have noticed a progression and an advancement of 20 days, and we know that the olive tree fly is attacking the olive tree before the fact that the fruit can reach 6 millimeters. So before the receptivity of the fruit, which happens during July, and this phenomenon corresponds to the heat. And since we have spoken about the advancement of blooming. The fruit becomes receptive at the end of June. The temperatures became favorable. We've been assessing the damages in 2010, and we have noticed that we have a value of 30% regarding the damages provoked by this insect. And we have this other factor which reflects the fall of production of the output of the olive trees. The soils constitute a non-renewable resource, and we have an overexploitation of soils, and it exposes soils to the loss of nutrients, and we have the rate of organic matters of soils, which is around 0.7%, and we can no longer speak about soils which can be used by agriculture, because we have poor and fragile soils, and so we have an erosion of lands, and we have the increase of tillage, which makes soils becoming damaged by the compacting provoked by the use of machines and tractors, and the soils have become a barrier which impedes water from entering the soils. We have been studying the permeability of soils, and you can say that about 80% of water resources remain at the level of surface water resources, and you have a very weak porosity of soils and very poor results in the field of water infiltration. Here you have the slide after a rain fall of 40 millimeters. The tree does not react because the front of water resources did not reach the olive trees, and most of soils where olive trees are grown are characterized by the wind recovering, and we have a low capacity of water retention. And when the roots do not find the water at the depth, we have only surface water sources which are exposed to heat, and we have an increase of CPR, and those roots are no longer useful. They do not benefit from any water resource quantity in the depth, and you see that there is no anchoring of olive trees. And when we use the tracks for rooting the olive tree, this operation has lasted 30 seconds. So the roots are no longer anchored within the soil. And the inadequate utilization of tools for the soils has been combined with the fragility, vulnerability of soils, and it leads to the erosion of soils. It leads to a negative impact, and the recharge of water has been reduced, and we try to improve the capacity of resilience of soils. And so as to remove every element which impedes the intrusion of water, we have tried to use the tools such as some kind of keys Now we are trying to sensitize our farmers so as to encourage them to diversify the utilization of tools and so as to reduce the passage of the tractors, and there should be organic amendments, knowing that soils are quite poor, and we try to improve the structure of soils and improve the resilience of soils. Concerning the diversification of tools, we have introduced during summer the tool with blades so as to remove the herbs and so as to reduce the evapotranspiration of soils. Meanwhile, we use the jamusi, which can break this coverage of tillage, and so as to enable rain waters to get into the soils in the depth, so as to improve the permeability of soils, which has reached 12 centimeters in winter. If the conditions are quite favorable, we are trying to rejuvenate the soils, because the roots have become quite old, so as to improve the olive tree and to enable it to rejuvenate its roots, and so as to make the olive tree avoid those non-functional roots. And we are acting in the field of a deep kind of cooperation between GIZ and the Olive Tree Institute, and we try to improve the nutrients of the olives, and we try to improve the soils, their quality, and so as to make water entering the soils. We tried to reduce evapotranspiration, and so as to have many bigger quantities of water resources. And for the spreading of margins, we tried to spread the margins so as to improve the quality of soils, the humidity of soils. The humidity in depth is our objective, and the spreading of margins has helped us to improve the germ biomass, and we have studied the spreading of margins, and we started to take measures within the International Center of Margins, and we have found that the spreading of margins reduces the olive tree erosion, and we have calculated the phenomenon of erosion and the erosion flows, and we have demonstrated that the calculated flows have been studied, and we have been in touch with Mr. Bergametti. It's an honor to have him among us. He has been working with us to make us better know the soil aggregation and the rise temperature phenomenon. And I am going to deal with composting as an alternative for the organic amendment of the soils. And above all, for the composting, we have implemented the compost so as to use it for the young trees, and so as to measure the depth, the humidity in depth, so as to keep the soil humid in the depth. And we started to spread some meters on the surface, and we try to valorize rainfall water resources during rainy years, and so as to make the soil able to stock big quantities of water resources. We have suggested some other measures for adapting to climate change. We try to improve the surface area for shading, and those aspects have improved the germ life within the soils, and we try to introduce a sort of luzerna within the soils, and we tried to provoke a kind of biological shading. We have used the Chameli variety, which is more resilient to drought, and so this variety has a root system which has been which is well developed, and we have used as grafting support, and we have another variety which does not resist to drought, but which is more productive, and we should have a new view, a new vision for the olive trees, so as to avoid to have olive trees which should be and which are very dry. And we have been selecting some olive trees which are younger, and we base our agricultural practices on diversification, and we have many possibilities with sun radiation rate which is quite high, and this allowed us to think about water desalination. And we have some other areas where we find very old olive trees. It's a system of gessus, of bridges. And we have olive tree areas with 5,000 olive trees, and you have this slide which represents 90% of the biomass elaborated by the olive trees. We have many resources and the know-how which should be valorized. We have to create a synergy among those components so as to be in compliance with the environment protection within a context of innovation, research, and of the creation of new alternatives, so as to develop the food industry and to have recourse to the valorization of technologies, and so as to develop eco-tourism. And I would like to say that the sustainable management of soils and the use of plant coverage and the organic methods can improve the carbon sequestration, and all those elements can improve the production of olives. If we do not do anything, we'll reduce production and will create social and environmental problems, and those problems, in the absence of adequate measures, could be at the source.
Présentation. Donc, Ahlam va nous présenter un peu la quantification de la variabilité climatique dans un grand bassin versant du sud méditerranéen à court et à long terme. Si j'ai bien fait la traduction.
Thank you. Thank you for giving me the floor to be part of this conference today. Thank you also for IRA for this conference and for this amazing organization. So I am Ahlam Gara, a PhD student at the National Agronomic Institute of Tunisia with collaboration of University of Montpellier II and UC Louvain, Université Catholique de Louvain. So I'm going to present my research study entitled Quantifying Climate Variability for Actual and Projected Conditions in a Large South Mediterranean Catchment, which is Majerda. So, the Majerda catchment, which is the only permanent waterway in Tunisia, have several problems related to data quality and quantity. Also, this catchment, this large catchment bordering between Tunisia and Algeria, presents important spatial and temporal irregularity of water resources and rainfalls, with a multiplication of extreme events due to climate change already observed and projected. So, which leads to the concentration and accentuation of extreme events such as prolonged drought and extreme events such as flash floods. These difficulties are now we are trying to understand the actual climatic function and to predict the future climate conditions within the Majerda. Is it okay? Okay. So these are the main difficulties to understand the actual climatic functioning and to predict the future climatic conditions within the Majerda. The main question here is, can we manage water resources in the northern region of Tunisia with integration of climate change? So the main objectives and goals for this research study are, first of all, to identify the observed rainfall and potential evapotranspiration variability within the Majerda catchment, and to quantify the projected increase in potential evapotranspirability and decrease in rainfall for different scenarios of climate change and through several climatic indices. So, these questions can be resolved through 5 steps. First of all, we are going to collect data and to select catchment. So the 5 or 4 catchments selected from the Majerda catchment are 2 from the left bank and 2 from the right bank, to highlight the difference between these 2 banks. So, according to this selection, we try to obtain the data, the daily observed data of rainfall and potential evapotranspiration. So we gathered 20 complete series of rainfalls, at least 35 or 36 years of continuous data. Then we used these data to assess the observed climatic variability already existent within the Majerda through variability, through statistical study, such as trends and breakpoints, coefficient of variability, standard deviation, means of inter-comparison. Also, we used the projected data obtained from the project Eurocordex framework for the RCP 4.5 and 8.5, and we selected the best bias correction method between linear scaling and distributed mapping. The fourth step is the identification of the climatic indices. So we used the already existent package in the air language, which is the AirClimDex, and the SPEI 30 days for daily data. And the final step is to use the projected data of precipitation and potential evapotranspiration. So we quantify the projected alterations of precipitation and potential evapotranspiration for the RCPs 4.5 and 8.5 till the end of 21st century. Let's highlight the Eurocordex project framework. It contains a variability of parameters that we can extract directly from the website. But we have to dynamically downscale at the regional scale with a mesh of 12 kilometers. So we used multiple combination of GCMs and RCMs and daily data of 12 kilometers grids, many climate parameters such as precipitation, minimum and maximum temperature, and potential evapotranspiration. We have 2 types of data. We have the historical or the hand case from the 1950 to 2005 and the projected data from 2006 till the end of the century. And we have three possibilities of RCPs, which is 2.6, the optimistic scenario, the 4.5, the realistic scenario, and the most pessimistic scenario, the 8.5. So the data used here are the observed and Cordex data. The observed data are obtained from the General Directorate of Water Resources. These are daily rainfall data from 20 rainfall stations for 4 different catchments within Tunisia. The potential evapotranspiration are calculated from the Ouda et al. And are obtained from the climatic data, minimum maximum temperature, and for the station Siliana, Beja, and Janduba from 1990 to 2016. The projected rainfall are then dynamically downscaled from the EM Cordex, Euro-Mediterranean Cordex website from the Majerda catchment. We selected only the realistic and pessimistic scenarios. So we have also an ensemble of 20 projected Euro Cordex climate data stations with nearest location. Now the observed rainfall station with high resolution using the regional climate model RCA4 with the 5 climate models under 2 emissions scenarios. For the potential evapotranspiration projected ones, we have data for 3 Euro Cordex climate stations with the nearest auto location to the website, to the observed climatic station from 1920 to the end of the century. The bias correction is to detect the difference between the observed data and the simulated historical hint case. So this difference is called model bias or model error that should be corrected. So we have, first of all, to select the bias correction method between linear scaling and distributed mapping, to identify the biases by parameterizing the bias when comparing observed data to simulated historical ones, and finally, to apply bias correction algorithm to obtain the projected corrected data. The study englobes 4 catchments, 2 on the left bank and 2 on the right bank of the Majerda. So these are the observed rainfall variability within the Majerda catchment. We have a mean monthly interannual precipitations for the 4 catchment in Tunisia. The right ones are the catchment for the right bank, and the left ones are the catchment for the left bank. So it's already presented here from simple presentation of mean monthly interannual data, the large difference between the stations of these catchment. So the station of, for example, the Feja station can reach in the month of January 180 millimeters. However, the stations in the lower and medium valley, which is situated on the right bank of the Majerda, does not exceed 60 millimeters per month. The same month, which is January. So rainfall vary between 400 and 1,200 millimeters per year. The standard deviation also is remarkable difference between Makthar station, which is located on the right bank of the Majerda, and Aindaba, which is located on the left bank of the Majerda. The coefficient of variation also vary between 15% and 120%. These are only statistical coefficients which are showing the already existing difference. So this is the accumulation probability of appearance for the studied rainfall gauges within the Majerda. The same as the mean monthly interannual. These are the yearly accumulated data. The stations for the right bank are more homogeneous than the left ones. We remark a large difference, partially explained by the important gradient of altimetry between these stations. For example, the station of Feja is located, for example, at 700 meters, and the station of Siliana at 140 meters of altitude, approximately. So these are the observed potential evapotranspiration already variability within the Majerda catchment for the 3 studied stations, which are Beja, Siliana, and Janduba. We remark a tendency to increase starting from the year 1997 till the end of the observed period. So the variability of potential evapotranspiration is here, but less important than the one obtained for the precipitation, which is concordant with Mr. Yad, which said because of potential evapotranspiration is largely affected by temperature. These are the projected rainfall within the Majorda catchment from 2020 to 2100. So here, for the 4 catchments, for the 4 catchments, with the 2 scenarios of climate change, RCP 4.5 and 8.5. So there is a tendency to decrease, an important tendency to decrease for the scenario of 8.5. However, for the scenario 4.5, there is no significant decrease tendency. The evolution of the projected rainfall within the Majorda catchment, these are the evolution of mean monthly interannual difference between the observed and the projected ones for the 2 scenarios, RCP 4.5 on the bottom, on the up, and on the bottom 8.5. For the Shim2 firm station, which is one of the stations between the 20 located on the left bank of the Majorda. We can remark that for the RCP 4.5, the decrease is between 8% and 10% in mean, and for 8.5, it is between 12% and 17%. However, the station ENM, Sicilian ENM, and Anbeya presents the most important decrease for the stations. These are the projected potential evapotranspiration with the Majorda for the period 2020-2100. So as we can see, also same for precipitation, the potential evapotranspiration for the scenario 4.5 doesn't present any significant trend. However, for the 8.5, presents an important increase for about 300 millimeters for the station of Siciliana. The same comparison between observed and projected mean monthly interannual potential evapotranspiration for the 3 stations, for the 2 scenarios, and for periods between short term, medium term, and long term, between 2020, 2040, and 2060, 2070, and till the end of the century. So the station of Siciliana will present a decrease of about 44% for the scenario of 8.5. Another 2, please. These are the extreme precipitation indices for daily time steps, which are extracted from the AirClimDex package. It presents 27 climate indices. We selected only 8. Between the simple precipitation and density, the max 1 days, max 5 days, the number of heavy precipitations, the consecutive wet and dry days, and the very wet days. This is a presentation, a zoom to one station, which is also located on the left bank of the Majorda, the Shim2 firm, presents an important decrease in total 95% of precipitation, and also concordance with Mr. which is the prolonged drought, which is the augmentation of number of dry days and also of wet days for several stations. This is the daily SPI 30 for the Ragai catchment for the RCP 4.5 and the RCP 8.5. Well, the difference between 8.5 and 4.5, which is the tendency to prolong drought, which is, for example, 8.5 starts the drought between the negative value from the month 4, which is April, to the month 10, which is October. However, for 4.5, it starts from April to September. To conclude, we first of all presented the historical climatic data assessment. We also selected and applied the bias correction method. We presented the temporal evolution of potential evapotranspiration and precipitation till the end of the century, compared with the historical ones. We also used the AirClimDex precipitation indices and the SPOI indices to assess the evolution of climatic indices by the end of the century. So the several statistical tests and indices to assess actual climate conditions show tendency to increase for P, precipitation, and potential evapotranspiration over the studied historical period with at least one rainfall station with breakpoints. Also, the linear scaling showed, bias correction showed a perfect fit with the observed rainfall data. The climatic indices showed the concentration and accentuation of extreme events, prolonged drought, and flash floods, and the important decrease in precipitation increase in potential evapotranspiration, especially for the most pessimistic scenario, which is 8.5. These are the limits, the perspective, and next steps to be used. So first of all, the limits are mainly the climate projections are only estimations that can give a skewed point of view and can't be confirmed yet. We are ongoing about the future. The difficulties that I personally lived, which is the serious problem when collecting data, accessibility, quantity, and quality, and of course the downscaling and the bias correction process needs the use of performant computers. The must-do first one is to assess the runoff evolution facing climate change with a measure data through robust and hydrological models to give these results for the frameworks and the stakeholders. And a must-do too is the use of the most recent projections in order to minimize the uncertainties related to the climate projection, the SSP2, P2, 4.5 and 9.5. And thank you for your attention.
Merci Ahlem. On ne peut pas présenter toutes les données de thèse en 10 minutes. Hein, donc, je sais que vous avez plein d'informations. Merci Ahlem. C'est Damasma. Ça c'est en ordre. Madame Asma va nous présenter Moderating Effect of Technical Efficiency on Farmer Perception of Vulnerability Factor and Adaptation and Tension and Contrasting Climate Risk Level Area en Tunisie. C'est très long, comme titre de communication.
Thank you. I shortened that. So I will not I will not take a lot of time because some results are presented yesterday. So for coping with coping strategies of farmers, اسمع في روحي بالقليل. So here we present the conceptual model that presents the relationship between different modules when coping with using coping strategies with farmers. So these strategies, this coping strategy depend on risk experiences and risk perception of farmers, and there are also external factors. So if you remember, yesterday we see that there is very kinds of level of yield. So we have actual yield, water limited yield, and attainable yields. And there is a gap between these kinds of yield. So the gap between actual and water limited yield is called the technical efficient yield, and it depends on agriculture practices. So if we decrease this gap, we can move forwards to efficient yields that can cope with water scarcity. So our hypothesis here is that technical efficiency could be used as an indicator for efficient farmer management and adaptation strategies. The external factors in this conceptual model could be environmental factors, they could be economic factors, and they could be social factors. So the question is, which external factor prevails when farmers will choose his adaptation strategy? To answer this question, we will, our methodology is based on an exhaustive survey which presented yesterday. So this survey is carried out into contrasting irrigated area, arid and subhumid in Tunisia, on a sample of 100 farms. We used the odds ratio techniques, relative risk, and multivariate analysis to explore our data. So we also estimate technical efficiency of all the farmers for this survey, and for all crops, faba bean, oat, onion, wheat, tomato, barley, potato, sugar beets, and these are the magnitude of technical efficiency farmers for these two areas. We will present here the significant external factors, only the significant external, which are different from agricultural practices that impact technical efficiency. So we see that decision making impact the technical efficiency, and when farmers use a professional way, professional help, he can increase his technical efficiency. The number here is for the coefficient of regression, the logistic regression, and I will use it after. The access to credit also improve the technical efficiencies of farmer, and when we move through negative response to positive response for access to credits, farmer are more likely to increase his technical efficiency. The same results, we found the same results for access to information. So when farmer have more access to information, he can improve his technical efficiency. And the climate change, when he's convinced about climate change effect, also we can find more efficient farmer convinced of climate change impact than non-convinced. Same result also for biotic stressor and disease stressor. If farmers are convinced there is threats, biotic threats, it is the probability of increasing technical efficiency is increased. So aridity. The aridity decreases the technical efficiency, and when we move to subhumid area to arid area, there is a pressure of the aridity on the behavior of farmer. So to summarize, because our first question is which prevails between all these factors. So we see here when we use the coefficient of the logistic regression, that the socioeconomic factors prevails on farmer technical efficiency compared to environmental factors. So at least two conclusions can be drawn here, that our professional process is efficient because they succeed to improve technical efficiency when farm use their help. The second conclusion is that there is a gap of awarenesses in farmer community about environmental risk, and these awarenesses impact highly the technical efficiency. So if also we compare the adaptation of this is a factorial card of adaptation intention of farmers and the fruits. So the fruits are put here in with the symbol mark. So we have access. We have the climate change. This work. Doesn't work. So we have the climate change, we have the loss of soil fertility, the lack of technical assistance, of mechanization and disease. And we see here that in the center of this figure, that the most dealing concerns of farmers are the availability of water and inputs. So even if farmers are, so it is a secondary concern for farmers, the environmental threats, and even if they are convinced about these threats, and we ask them what is your coping strategy, they are inactive and they can't answer. So when we asked them about changing crops, if they are willing to change crops. So we found that farmers convinced about environmental factors are more likely to be willing to change their crops than farmers who are not convinced. Are also farmers who belong to sub-humid area are also more willing to change their crops than farmers who belong to arid area. So to conclude, we saw here that driving factors such as access to information and credit boost farmer intention to adapt and allow the improvement of technical efficiency. So policymakers have to improve access to information, increase technical efficiency, and they also have to improve the technical assistance for farms. And thank you for your attention.
Merci Asma, vous avez fait 10 minutes exact. Merci beaucoup. Bon, on passe à la présentation suivante. Wassar Fatma va nous présenter un peu l'évaluation des impacts du changement climatique sur la production d'olive dans le sud tunisien.
Okay. So, good morning, everybody. This is me, Fatma Wassar. I'm working as an assistant professor at the Higher Institute of Water Sciences and Techniques, and I'm a member of the laboratory of arid and Oasian culture. Today, I'm going to present work in collaboration with the National Research Council of Italy, Institute of Biometeorology, entitled Assessment of Climate Change Impacts on Olive Production South of Tunisia. As you may all know, the olive tree is an ancient traditional crop in the Mediterranean basin. Olive trees are indeed considered as one of the most suitable and best adapted species to the Mediterranean type climate. However, new challenges are predicted to arise for climate change, threatening this traditional crop. The Mediterranean basin is considered as climate change hotspot, as future projections hint at considerable warming and drying trends. Changes in olive trees' suitability have already been reported over the last few decades. In this context, climate change may become particularly challenging for olive growers. Despite their resilience, olive trees now face an existential threat for the changing global climate. The destructive impact of climate change on olive trees is already visible from Tunisia to Palestine and Turkey to Italy. South of Tunisia is considered as the most vulnerable region to climate change impact, and the governorate of Mednin, which is our study area, is also considered as one of the most vulnerable regions in the south. Accordingly, and from here emerges the objective of our study, which is the assessment of the vulnerability needed to label major factors influencing olive production and build an adaptive strategy to reduce their impacts. So in order to assess climate variability and climate change's impact on olive production, we used the data of olive production of Medellin governorate from 2003-2004 season to 2012-2013 season. Climatic data used are precipitation and temperature, collected from Medellin station for the period between 2002 and 2013. We started with the analysis of olive phenology so we can understand the progress of olive stages during the year and build hypotheses for possible impact of a climate in these different stages. The differentiation of olive phenology and formulation of climate impact hypotheses were based on the state of the art and the knowledge of local farmers. So we took on consideration precipitation and temperature due to the availability of data gathered. Here we have the table number 1 summarizing olive phenological stages and the corresponding climate impacts hypothesis. As I mentioned before, this is the result of previous scientific research and a survey we did with the local farmers. We start with the assessment of precipitation impacts on olive production. We use the data of total amount of precipitation observed in the season of interest. In order to have clear results for interaction analysis between olive production and precipitation, we choose to normalize all the data. Results of correlation are summarized in this table, and we selected hypotheses with correlation results above 0.5 to be interpreted. We started by analyzing interaction between precipitation of September-March season with olive production of the following year. Here we noticed a clear coherence between the amount of precipitation and on the season of interest and the production of olives with a positive coefficient of correlation of about 0.86. This indicate that olive production in this region rely strongly on precipitation amount during this period. We analyzed then interaction between precipitation of November-March season with olive production of the following year. We selected this period considering the rainy season of the year and the start of the olive life cycle. We noticed a strong consistency with the coefficient of correlation of 0.95. September-March season with high amount of precipitation led to an increase in olive production of the following harvesting and vice versa. This increase depends strongly on the rainfall amount stored in the soil during winter rest, which boosts trees' productivity for the following year. It depends also on the total amount received during the stage of flowering. One of the hypotheses formulated is that drought during flowering period leads to an incomplete flowering and poor fruit set. So in order to assess this impact, we analyzed the correlation between precipitation of March-April season with olive production. We noticed a strong interaction with a coefficient of correlation of 0.79. Precipitations during March-April season help establish a prosperous condition for bud development and bloom, leading to an increase of quantity of olives. Now we move to the assessment of temperature impacts on olive production. As we did with the precipitation, here we analyze the temperature effects on olive production, and assessment of this impact is taken into consideration in terms of olive production quantity. We use it for that, normalized data of mean maximum temperature over the season of interest, number of days with the temperature above 40 degrees, and normalized data of olive production. We examined all hypotheses built for temperature impacts, and here we have the summary of correlation coefficient results. and similarly to the precipitation, we choose only hypothesis with the correlation above 0.5. We analyzed the interaction between olive production and mean maximum temperature of March-April season. We noticed a good consistency with a coefficient of correlation of minus 0.65. Hypothesis for this case suppose that high temperature leads to an incomplete flowering and to a poor fruit set. This hypothesis is therefore confirmed. Season with low mean maximum temperature result in an increase of olive production quantity due to better conditions for bloom and bud development. We analyzed also relation between olive production and mean maximum temperature of September and October. Hypothesis here in this case was that high temperature damages foliage and can cause fruit fall. We remark good correlation with a positive coefficient, coefficient of correlation. And here we have the coefficient was about 0.61. This is in opposition to the hypothesis suggested. So this result can be interpreted by the fact that olive trees have a preference to hot weather for better olives grow and ripening. Temperature in September, October can lead to a decrease in olive production in case of extreme events of heat waves that damage fruit and foliage with high temperature. Finally, we evaluated the impact of temperature of June-August season on olive production in terms of number of days with temperature above 40 degrees. We noticed a moderate interaction with a coefficient of correlation of minus 0.52. So June-August season correspond to fruit development stage. Accordingly, temperature above 40 degrees may cause fruit drop, decreasing therefore olive production. We conclude, during this stage of work, we determine the most sensitive phenological stages of olive trees to climate variability. After applying some statistical analysis, we defined climate factors having impacts on olive production. The interaction between precipitation of September-March season with olive production showed a clear coherence between the amount of precipitation of the season of interest and the production of olives. The same interaction with precipitation of November-March displayed a strong consistency with a high coefficient of correlation. Seasons with low mean maximum temperature during March-April season result in an increase of olive production quantity due to better condition for bloom and bud development. The relation between olive production and mean maximum temperature of September-October season presented a good correlation with a positive coefficient of correlation. We noticed also a moderate interaction between the temperature of June-August and olive production with a negative correlation coefficient. June-August season correspond to fruit development stage. So temperature above 40 degrees may cause fruit drop, decreasing therefore olive production. And as a next step, we are planning to update our data till 2022 and then simulate olive production based on results from analysis of climate factors impact on olive production using the multiple regression model. And thank you for your attention.
Merci Fatma.
I was running.
Pour cette présentation, vous avez fait 10 minutes aussi. Hein, merci.
Merci.
Khouloud Qadr, elle est là. لا اعطوني اسمح. L'impact de la sécheresse sous l'effet changement climatique dans la région de Madjerda, non?
Non, la sécheresse projetée
projeté.
dans un contexte de changement climatique.
10 minutes.
Good morning, everyone. I am Khouloud Gader, a PhD student from the National Agronomic Institute of Tunisia, with collaboration of UCL in Belgium. In the beginning, I would like to thank Iram Mednin for this opportunity, and I am going to talk about projected drought under climate change using deep learning in a semi-Mediterranean region, the major catchment in northern Tunisia. First of all, I would like to talk about climate change impact, model prediction. According to model prediction, the most significant manifestation of climate change is decrease in precipitation and increase in temperature, causing reduced stream flows and multiplication of extreme events such as drought and flood can be notified. Tunisia, as a Mediterranean region, is characterized by its climatic variability. Climatic variability and climate change will increase this variability, allowing projected climate condition. In this context, the objective of this study aimed to apply the empirical statistical downscaling method to obtain precipitation and temperature projection for 4 meteorological stations by 2100 from the RCP 4.5 and RCP 8.5 scenario of GCM MEROC 5. To use the hydrological modeling in order to quantify the effect of climate change on the hydrological regime in the major catchment in Tunisia, and to characterize the projected climate condition on the major catchment of Tunisia. The methodology consists in using the modeling process adopted in the impact study of climate change in hydrology, which consists on 4 steps. The global modeling with the MEROC 5, the 2 scenario of emission of green gas emission, the RCP 4.5 and the RCP 8.5, and the regional climate modeling using the empirical statistical downscaling method, which provide projected variable temperature and precipitation that are used to implement the rainfall runoff model GR2M, allowing to quantify the projected climate index. Let's study area, the major catchment in Tunisia, which is characterized by its topographic and climatic variability. In this work, 4 meteorological station is used, and 4 sub-catchment located at the left bank and the right bank of Medjugorje. Let's start by climate modeling. The used data are the reanalysis data from the NCEP reanalysis project, the historical and RCP emission data for RCP 4.5 and RCP 8.5, the historical and the future data for the MEROC 5
GCM, and the historical monthly rainfall data for 30 years collected from the National Institute of Meteorology in Tunisia. The global model used is the GCM MEROC 5. We used a machine learning algorithm to test 6 different type of model for linear regression model, the random forest model, and the neural network. And 6 predictors are considered and some fitting criteria. The downscaling process consists, first of all, on the analysis of correlation pattern based on the general circulation pattern most influencing the regional climate. Then the determination of area of significant high correlation. Next step is the extraction of data from the reanalysis and the GCM outputs. Afterward, the extraction of the predictor table from regression model, and the fifth step is the objective selection using the variance inflation factor, which is an approach to identify the collinearity between a predictor, then the model fitting, and the cross validation, which is the last step of validation of the choice of the best model. To reach the projection steps, which provide the time series interannual, mean monthly time series of precipitation and temperature. To obtain a monthly time state, we used the NECIM-R package to do the temporal disaggregation. Projected precipitation allows degree of for each catchment and according to the two scenario, while the temperature will undergo an successive increase. The appropriate model to project the temperature at all stations is the linear GLM model, which proves that temperature modeling is simpler than precipitation modeling, which because of its heterogeneous and random character leads to enormous difficulties in the simulation of its local dynamics. The projected precipitation will decrease. The decrease of precipitation will vary between 10% at the Selena station to 14% for Beja station, according to RCP 4.5, and according to RCP 8.5. Vary between 20% at Le Caf station and 45% at Beja station. For the increases of temperature, they vary between 1.3 at Le Caf station to 3.5 at Selena station according to RCP 4.5, and between 3.5 at Le Caf station to 6 degree at Selena station. Let's move to the hydrological modeling.
minute.
نعم شوفوا هذا
Easy.
the projected data for temperature and precipitation are used to provide the projected runoff for each station, and according to the two scenario, we used the GR2M model developed under the RGR air package. For the historical period, we calibrate the model for which shows good performance for all the four catchment. The calculated Nash value is good for Sarat and Siliana catchment and very good for the other catchment. All the KG value are good and all the RSR value are very good. Then the parameter of calibration of the GR2M in the historical period are used to provide the runoff, projected runoff for different projected period, and for according to the two scenario. For the four subcatchment, like this example. Based on the projected runoff, we calculated the future change in the annual mean flow, which show that for all the projected period, the decrease vary between 23.5% in Bohertma and 43% in Kaseb, according to RCP 4.5, and between 37% in Sarat and 17% in Kaseb, according to RCP 8.5. Then the collected projected rainfall, temperature, and runoff are used to calculate the standardized climate indices, such as the standardized precipitation index, the standardized runoff index, and the standardized evapotranspiration index. Over the historical period, the calculated SCI value range from 1 to 0.1 with a median close to 0 for the different subcatchment, which mean similar climatic condition, reflecting variation between moderate wet and dry condition, with the presence of some severe drought and humidity, reflected by the extremes.
Conclusions, please. Conclusions.
Yep. For according to RCP 4.5, calculated SCI allows moderate condition for all catchment, except for the last period, which trend for drought, moderate drought, and for according to RCP 8.5, the dry condition become more pronounced. To conclude, the projected rate of precipitation decline and temperature increase vary between stations in the study area. The model which simulates precipitation in the major vary from the sample GLM to the most complex random forest, while the GLM is the most appropriate to simulate temperature at all the study stations. The calculated SCI affirm the impact of climate change in the studied subcatchment. Decreasing trend of SCI is reported while the climatic situation still remain in moderate wet and dry condition until 2017, whereas by 2100, the drought would be frequent and more intense, reflecting a significant change in the rainfall and hydrological regime in the major dam. And thank you for your attention.
Thank you, Khulud. To the last presentation. Ikhlas 2. 2. Okay, Ikhlas will be presenting on adjustment of crop coefficient of wheat using remote sensing based vegetation index and effects of climate change projection on irrigation in Bouselem Jandouba region, northwestern Tunisia. You have 10 minutes.
Bonjour à tous, je vous remercie pour cette opportunité. Aujourd'hui, je vous présente ce travail intitulé Ajustement du coefficient de culture cassée du blé à partir de la télédétection et les effets de la projection du changement climatique sur l'irrigation dans la région de Bouselem Jandouba, nord-ouest de la Tunisie. Alors, le blé d'hiver arrive au premier rang des grandes cultures tunisiennes avec en occupant 48 700 hectares par an. Cependant, la production des céréales en Tunisie, étant surtout pluviale, reste très sujette à la disponibilité de l'eau, aléas climatiques et pénurie d'eau. La disponibilité de l'eau sera accentuée plus par le changement climatique, ce qui peut affecter le rendement de cette culture. Ce travail admet comme objectif le développement d'un modèle de calcul du coefficient culturel à partir des données de la télédétection, la quantification des besoins en eau actuels de la culture du blé et l'adaptation de la culture du blé au changement climatique. On commence la partie matériel et méthode par la présentation de la zone. Alors, la parcelle de blé d'El Kodia se localise à l'est du site du Rian-JC, à une distance de 5 km. Elle est située dans le gouvernorat de Jandouba. Elle s'étend sur une superficie de 0,4 hectares. Alors, notre étude se divise en deux parties, partie de l'étude de l'état actuel et partie d'étude de l'état projeté. En état actuel, on commence par la collecte des données climatiques de la période des 5 campagnes agricoles de 2015 jusqu'à 2020 à partir de la station météorologique d'El Kodia. Ces données sont utilisées pour la détermination des degrés jour de croissance afin d'ajuster les durées de stade phénologique qui sont exprimées en temps thermique avec une température de base de blé qui est égale à 0 degré. Alors, de sorte que la plante passe d'un stade végétatif à un autre lorsqu'elle reçoit une quantité de cumul de chaleur qui lui permet de déclencher l'étape suivante de son développement. Cela nous permet de l'amélioration du coefficient culturaux par une simple interpolation. Après, on passe à l'estimation de l'ETC, le tiers et le besoin net et brut de la culture. Pour le téléchargement des images satellitaires à partir du site USGS, on a opté pour le Sentinel-2 qui nous a fourni les valeurs nécessaires pour le calcul des individus et cela nous a aidé à coupler la relation entre les cassés et les individus et on finit par la validation du modèle obtenu. On passe maintenant aux études de l'état projeté. On commence par la projection des températures et des précipitations à l'horizon de 2041-2070, qui sont la base de la choix des scénarios climatiques. Ce choix de la date de semis compte sur la meilleure période dans les conditions climatiques, lequel favorise une croissance normale de la plante. Pour ce faire, 5 options de semis sont testées, semis très précoce, précoce, fixe, tardif et très tardif. Après, on détermine le degré jour de croissance et le cassé amélioré pour chaque scénario. Avec le logiciel CropWatt, on va déterminer le T0 et afin de calculer le TC et le besoin net. Ce calcul nous permet de déterminer le scénario le mieux adapté et le gain hydrique prévu. On passe maintenant aux résultats et discussions. Pour le suivi de la croissance du blé, on a calculé le degré jour de croissance durant les campagnes de la période 2015-2020 afin d'ajuster les longueurs des stades du cycle végétatif. La durée moyenne du cycle du blé est comprise entre 6 et 7 mois. Le cycle du blé a été réduit par rapport aux références présentées selon les bulletins de la FAO 56. Ce raccourcissement est principalement remarqué pendant la phase 2, de croissance. De près de moins 50%. Alors, l'analyse de l'évolution temporelle de cassé amélioré et des individus, max, min et moyenne, obtenue de la télédétection, indique une similarité qui reflète la forte relation qui nous encourage pour le développement du modèle cassé en fonction des individus. Par l'analyse de la régression linéaire multiple entre les cassés améliorés et les individus max, min et moyenne, on a abouti à un coefficient de détermination multiple égal à 0,83. Le modèle de régression obtenu est le suivant. Cassé égal à 0,23 individu min, moins 0,69 individu max, plus 1,51 individu moyenne, plus 0,38, plus 0,38. Alors, la variation des valeurs de cassé améliorée et celle des prévisions de cassé par le modèle obtenu semble analogue en termes d'évolution, comme vous voyez. Cela affirme la forte relation indiquée par le coefficient de performance. Et pour tester la fiabilité de notre modèle, on a utilisé les données de la campagne 2020-2021 pour 2 sites différents, El Kodia et Shbika. Les valeurs de coefficient de détermination R carré entre les cassés améliorés et les cassés estimés par le modèle cassé individu sont proches de 0,9 pour les 2 cas. Cela indique qu'ils sont significativement corrélés et ce qui implique la validité de ce modèle. On passe maintenant au calcul de l'ETC. L'ETC du blé varie de 410 à 475 mm pour les campagnes 2015-2016 et 2018-2019. Pour les besoins bruts, elle varie entre 200 et 500 mm. Ces résultats, pour toute la période d'investigation, indiquent qu'il convient de revoir la conduite de l'irrigation, puisqu'on atteint près de 500, puisqu'on atteint des apports d'irrigation de 312 mm en 2018 et 585 mm en 2017-2018. On passe maintenant à l'étude de l'état projeté. La température moyenne minimale projetée du mois le plus froid serait de 7 degrés en janvier et la température moyenne maximale projetée du mois le plus chaud serait de 42 degrés en août. La pluviométrie mensuelle la plus élevée serait observée en septembre avec une valeur de près de 144 mm. Les dates de semi-dynamique sont choisies selon le scénario en faisant coïncider le cumul de degrés jours de croissance à l'époque la plus pluvieuse, permettant de combler l'évapotranspiration par la valorisation de la pluviométrie. Les dates de récolte sont obtenues par le calcul de degrés jours de croissance cumulés selon la date de semis choisie, sont aux alentours de fin mai, début juin pour le scénario standard. Ainsi, pour le scénario précoce, elle est entre début mai et début juin. En cas très tardif, elle atteindrait 26 juin. En revanche, les dates de récolte pour le scénario très précoce ne dépassent pas fin mai. Concernant les longueurs du stade phénologique, on remarque que le nombre de jours de la stade 1 augmente légèrement en cas de semis tardif par rapport au semis précoce et elle varie réciproquement pour le stade 4. Pour le T0, elle est projetée, pour le T0 projeté, elle varie entre 7,4 mm par jour en juin et 1 mm par jour en décembre. Ceci est expliqué par l'augmentation de la température maximale et minimale. Les projections de l'ETC montrent une tendance à la baisse dans le cas de semi-dynamique très précoce avec un minimum de 306 mm et un maximum de 412 mm en comparaison à celle dans les autres cas de semis. La pluie efficace au cours de la saison de blé selon le scénario variable très précoce est la plus élevée. Le scénario très précoce permet de mieux valoriser l'augmentation des précipitations de l'automne qui permettent de combler d'une certaine façon la baisse des précipitations hivernales. Ainsi, elle varie entre 41 mm en cas très tardif et 425 mm en cas très précoce. La comparaison de la variation des besoins en eau nette de la culture de blé entre les 5 scénarios étudiés montre que la quantité d'eau nécessaire à la plante pour sa croissance diminue dans le cas d'un semis très précoce qu'un semis précoce, ainsi celui fixe, tardif et très tardif. En effet, il pourrait être nul en adoptant le scénario très précoce et atteindrait 390 mm en adoptant le scénario le plus exigeant qui est le plus tardif. De ce fait, les semis très précoces effectués au cours de la troisième décade du mois d'octobre, au début de la pluie utile, sont les plus recommandés du point de vue hydrique, car ils permettent le blé de mieux valoriser les pluies automnales et de s'échapper au stress hydrique et thermique. Finalement, on peut dire que pour le gain hydrique, il est prévu que la quantité d'eau économisée moyenne serait de près de 85 mm par saison, avec un maximum de 206 mm et un minimum de 24 mm. Pour conclure, on peut dire que ce projet nous a permis de déterminer les cassés par télédétection et développer un modèle de cassé NDVI, d'évaluer la conduite de l'irrigation du blé à l'état actuel et d'explorer des voies d'adaptation de la culture du blé aux projections climatiques. Merci.
Bon, merci. Merci pour tous les conférenciers qui ont présenté aujourd'hui des présentations intéressantes dans le changement climatique. Reste encore une? Oui. Non. Déjà, il ne reste pas beaucoup de temps, malheureusement, pour la discussion. Mais quand même, on va prendre 10 à 15 minutes maximum pour écouter vos questions. Et donc, j'invite les conférenciers à essayer de répondre à vos questions. Donc, Fadlou. Please.
Thank you. Ihab Jnad from AXAD. Yeah, I have several questions. First of all,
just one.
One question. Okay. I will sum all of them in one question. Yeah, for the study of climate change on olive tree done by Fatima. Yeah. So I guess AXAD did a lot of study on future impact, not on historical impact. And I proposed to Dr. Muhammad, I'm not sure if she's from the Institute of Medellin or no. Maybe we can do joint study on the same area for olive tree in Medellin, but for future projection to see the impact. This is proposal. My question for the study on Majrada, on the impact of temperature, 3.6 is too high for 4.5 scenario. Khulud, I guess she did. It's too high, I mean, for the scenario 4.5, and I guess maybe this need to be rechecked. AXAD did hydrological model for Majrada using HMS, and maybe we can compare the study done by AXAD and for also for drought in DC. So maybe we can compare this later. Thank you.
Thank you.
صباح الخير. بونجور. محمد النصري، مدير إدارة الثروة الحيوانية أكساد. أن السؤال أولا ساعة نحب نشكر كل المحاضرين على المحاضرات وعلى الدراسات القيمة. ثانيا سؤالي عام، هل هذه المواضيع تم أخذها من الحقل ومن مشاغل المزارعين والفلاحين والمنتجين، أو هي يعني مشاغل بحث للجامعات والكليات؟ فالنتائج هامة. على السؤال الثاني، هل تم يعني بعض النتائج تجربتها على مستوى الحقل، على مستوى الترع على الأقل؟ شكرا.
شكرا. تفضل.
Bonjour, merci de donner la parole. J'avais une question, c'est pour Monsieur Abichou. Au niveau du travail du sol sur au niveau des pratiques sur les oliveraies, au niveau du travail du sol, donc est-ce que le labour a lieu seulement pour quel est l'objectif du travail du sol? Est-ce que c'est seulement pour augmenter l'infiltration, ou est-ce qu'il y a d'autres objectifs comme limiter la propagation des mauvaises herbes? Donc je voudrais une précision pour savoir voilà, est-ce que les agriculteurs pratiquent le labour et pourquoi ils font autant de passages sur les oliveraies.
السلام عليكم. سؤالي للدكتور عياد، على شكرا على المحاضرة القيمة. سؤال على التغير المناخي، فيه يعني عمل كبير للمجتمع المدني وأحيانا حتى على مستوى الحكومات على موضوع التغير المناخي. في قارة هي يعني مسؤول على بورشن صغير جدا من التلوث، من الجرين هاوس افكت، اللي هي أفريقيا. هل تشوف فيه الموضوع هذا افكتيف فعلا؟ شيء ثاني، انا شفت انك انت ما ذكرتش الكوفيد بانديميك تاثير على البلانيت، وهذا يقودني لان نسال ان هل الارض فعلا توازن في نفسها بعد فتره؟ لان في عصور قديمه جدا وازنت الأرض نفسها، ارتفعت درجات الحرارة، تغيرت طبيعة الأراضي. وهذا سؤال جدلي في التغير المناخي للناس اللي مع التغير المناخي والناس اللي ضد. فهل الأرض توازن في نفسها ولا؟ لأن لما احنا نستثنوا كل العوامل ونحطوا الإنسان فقط والشركات والدول الصناعية، أنا نشوف فيه إيجو كبير للإنسان، يعني غرور مرتفع جدا. آخر حاجة، تويتوا سؤال واحد بس معلش. آخر حاجة نبي نسأل على الجانب الإيجابي اللي أنت وضحته على موضوع إنتاج من الكربون، المستوى متاعها هل كان على مستوى مجتمع مدني، المشاريع اللي ذكرتها هل كان على مستوى حكومات، باش إن تستفيد منها كل دول المنطقة. وشكرا.
Dernière question.
Thank you. My question to Dr. Munir, as he mentioned to the drought on olive trees, I think he should focus on the soil physical properties more than the drought itself, because as he mentioned, there are a lot of problems with soil physical properties as like soil stability aggregate and soil infiltration. I think he should in these properties more than the drought itself. Thank you.
Shukran. Merci. Juste deux petites questions. La première étant, on a remarqué que la majorité des travaux se font sur le bassin versant de la Medjerda. Bon, c'est explicable du fait que les données sont proches, les données sont disponibles et c'est proche de l'INAT, proche de... Mais il y a d'autres bassins versants qui méritent d'être étudiés d'une façon approfondie. Je m'entends par là le bassin versant de Houerb et le bassin versant d'El Fek. Parce que ces deux bassins versants ont une importance capitale au niveau de la production agricole et d'une façon générale au centre de la Tunisie. Deuxième question à propos de l'intervention de Madame Moselle Khlas. En fait, est-ce qu'elle a poussé cette étude? Parce que c'est une étude très intéressante du fait qu'on économise une quantité non négligeable d'eau. Elle a poussé au niveau de la densité des semences, au niveau de la densité des semences et la réduction de la période entre le semis et la récolte. Merci.
Merci. Dernière question, c'est Kamel.
Merci. Donc, en fait, j'ai une petite remarque concernant le plan de gestion de la sécheresse. Il y en a un autre qui a été développé, qui est complet avec une anticipation qui était en 2004 ou 2005. Juste une question, Simouni et Madame Fatma. J'ai vu que l'impact de la température, que je pense que c'est le plus dur à mitiguer, il y a deux impacts. Un impact immédiat, comme a montré Madame Fatma, sur la floraison et la coulure des fleurs. Je dirais que c'est la brûlure des fleurs, et un effet qui n'est pas immédiat, mais qui il y a une précocité et un allongement de la durée de floraison. Donc, au fait, est-ce que il y a plusieurs impacts au lieu d'un seul impact? Un impact qui va bouleverser le cycle biologique avec ses impacts négatifs, et un impact immédiat qui est plutôt physique sur les fleurs, Madame Fatma. Donc, au fait, il faut aller creuser dans ces deux sens. Et one question for Asma about the awareness of farmers about climate change. They are living climate change and facing the impacts of climate change. How they are not aware? My question is, in the perception, are they not aware about the possibilities of mitigation of climate change or adaptation to climate change, or are they not aware about the impacts of climate change while they are living there? Thank you.
Okay, thank you. D'accord, très rapidement, je vais donner la parole. C'est par Dr Laben pour répondre à ces questions. Et j'aime bien demander aux autres conférenciers de nous joindre pour pouvoir répondre aux questions, s'il vous plaît.
Je vais te répondre très rapidement. Pour le programme national sécheresse, notre ami a dit qu'il avait un programme national de la sécheresse de 2014. Moi, je pensais avoir bien fait. J'ai présenté le programme national de la sécheresse de 2020. Je pense qu'il est certainement plus complet. Concernant notre ami de l'Axad, moi, c'est vrai qu'en présentant les scénarios extrêmes et en présentant jusqu'à l'échéance 2100, ce que nous voulons, c'est avoir une vision globale. Maintenant, pour des études beaucoup plus spécifiques, on peut se limiter à l'horizon 2050, on peut se limiter à un scénario raisonnable qui est le scénario RCP2 4.5. En revanche, pour les projections de changement climatique, je ne suis pas d'accord avec vous. Je pense que chaque pays, au maximum, chaque région, peut-être l'Afrique du Nord seule, la Jordanie, la Syrie seule, mais chaque région procède à des projections de changement climatique sur sa région avec un downscaling le plus approprié possible et chaque pays, chaque région, chaque pays fait ses propres projections, ses études de vulnérabilité et il y aura beaucoup plus un partage d'expériences et de résultats. Mais standardiser tout, ça me paraît un peu difficile, surtout que nos régions, notre région est assez grande. La dernière question, الأخت من ليبيا باش نجاوب شطر جواب ونكملوا إن شاء الله في وقت القهوة. أنا يظهر لي جدل ما بين جدل في حكاية التغيرات المناخية. هذه نقاش أنا حسب رأيي تعدى وقته تعدى. تو نزيد نحكي فيه في القهوة حسب رأيي وقته تعدى. أنا حاجة بركة اللي نحب نقولها. نحب نقول إن البلدان اللي في طريق النمو فعلا هما ما همش طرف في المشكلة. ولكن نراهم يخسروا برشا إذا كانوا ما يكونوش طرف في الحل. ما نعرفش إذا كان فهم فساد بالكدا، معناها إذا كان ما يكونوش متواجدين وقت الناس تبدا تفركز على الحلول، راهو حتى حد ما ياخذ بعين الاعتبار المصالح نتاعهم، والبقية نكملوها وقت القهوة.
Merci. Alors, on va passer aux autres réponses. Dans 2 minutes, s'il vous plaît. 2 minutes maximum.
Concernant la première question, s'intéresse à travail du sol, donc passage fréquent. Donc, on travaille le sol, premièrement pour préparer le sol. Donc après, il y a le travail de printemps, c'est d'éliminer les mauvaises herbes, parce qu'il s'agit de zones arides, il n'y a pas assez de pluie, donc les agriculteurs veulent éliminer tous les herbes pour éliminer le... Et surtout, s'il y a des chiens-tons, donc ils font beaucoup de passages pour épuiser cette réserve. Et pendant l'été, ils utilisent pour aérer le sol, parce qu'il fait chaud, donc le sol est chaud, donc faire du passage pour aérer le sol. Pour la deuxième question, concernant la structure du sol, sur la structure du sol, il s'agit du sol sableux, donc très facile de se déplacer, donc l'érosion est facile. Pour le fondement organique, c'est dans le but d'améliorer les structures du sol et former des agrégats de sol grâce à la margine, surtout la margine, on a utilisé la margine, c'est parce qu'il contient des matières liantes, il lie les petites particules de sol entre eux et forme des agrégats de sol plus importants et résiste mieux l'érosion éolienne. Concernant la question de Sikemel, on a travaillé sur la température, surtout pour la température hivernale, elle a un effet direct sur la floraison.
So they are not aware about the impacts of climate change committee.
Okay. For Dr. Junaid, yes, I'm a member in the laboratory of aridoculture and Wazian culture under the supervision of Professor Kamal Nagues in Ira Medni. So it's my pleasure to collaborate, of course. I didn't mention in my presentation before, but this is what we are doing. This project has different parts. So in one part, we are modeling the olive production, and we are planning to make a projection, future projection for olive production and the impact of climate change on future. Yeah, okay. Thank you.
Alors, les hydriques sont testés du point de vue hydrique, mais on peut prendre en considération la densité de semis dans les prochaines études.
Merci. Alors, je suis sûr que vous avez d'autres questions, vous avez d'autres points à clarifier, etc. Vous pouvez en discuter plus tard si vous voulez. Une petite question pour notre président quand même.
سعياد سعياد قلت لنا ممكن من الحواجز الايجابيه هي الاوغمونتاسيون ستوك دو كربون في المناطق، لكن انا اتصور ان هذه دراسه تستدعي اكثر تدقيق على اساس ان نعرف الاوغمونتاسيون ستوك دو كربون مربوط ماتير اورجانيك اذا كان نحكوا على طاحنه الصوت سون تري بوفر ماتير اورجانيك. l'augmentation du stock de carbone et l'augmentation du taux d'humidité اذا كان طاحنه مثلا كبيره. بون نعرف ان الجانب الايجابي هو نون ترافاي دو سول يحسن ستوك دو كربون، لكن هذا جانب. لكن احنا في منطقه اللي هي التربه نتاعها قابله للتعريه، دونك ضد ماتير اورجانيك صعيب وما ثماش انكوبير فيجيتال. دونك لي بارامتر هذوما مانيش عارف اسكي دخلوا في الدراسه وقت يعملوا كونكلوزيون يقولوا ان المناطق الجانب الايجابي هو l'augmentation du stock de carbone في المناطق الطاحنه. دونك il faut prendre ça. Merci.
Alors, à la fin, je vous remercie tous. Donc, je remercie les conférenciers, les participants, et donc, comme ça, on termine cette session. Merci.
Merci beaucoup. Malheureusement, les collègues nous ont fait un peu de la pression. On a grignoté déjà sur l'autre session. On va raccourcir la pause café seulement 20 minutes pour reprendre avec la session de la DGACTA GIZ. C'est Fawzi, c'est Mousfa, à 11h45. بربا une autre remarque pour les posters اللي عندهم les posters بتاع امس نحيوهم. خاطر on va demander pour la session de topic 3 et 4.
الكي نوت فازت.